Okay, we are now into finding zeros of polynomials. In chapter 3.2 we did this, so we're going to cross this out, and this is going to be chapter 3.3. So what we did last section was we were given a polynomial and we were told to find all the intercepts or solutions. So here we look, we don't see a GCF. I can't factor it by saying x times x and then pick two numbers. It's not a trinomial where a is 1. So I notice there's 4 terms. Something goes off in my head and I see that there's grouping. So between the first two, they have a GCF of x squared. So I'm left with x minus 2. And if I look at the second one, oh, I can't find that. So grouping doesn't work. Well, this is technically unfactorable. Maybe if I had something to work with, I could find the other factors. So for instance, if you were in 7th, 8th grade and your teacher said, factor 56, it's what times what? And you weren't sure, and your teacher said, okay, well, one of the factors is 7. What are the other factors? You could use division to help you find the other factors, and then you could figure out here what all your zeros would be if you knew all the factors. So this next section, you're going to be given one of the factors and you're going to use division to find the other. But how do you use division with polynomials? You're going to learn 2 methods. You're going to use long division and you're going to use synthetic division. Now long division, we're going to do first. We're going to take our polynomial of x cubed. Now, if we didn't have an x squared, we'd put 0x squared, but we do, so it's negative 2x squared. And if we didn't have an x, we'd write x, well, 0x, and so on and so forth, but we do. Now let's recall back to like 2nd grade when we had long division. And I said, okay, take 225 and divide by 5. You would tell me that 5 can't go into 2, but can 5 go into 22? And you'd say, yeah, 4 times. Then you'd go back and take that 4 and multiply that 5, and you get 20. Then you're left with a 2. Well, 5 can't go into 2, and it shouldn't because the number should be big enough where you can't. And then you bring down the 5, and 5 goes into 25 5 times, and make sure 5 times 5 is 25. When you subtract, your remainder is 0. Do you remember that? Okay, we're going to do the same concept, though, but with polynomials. So you look at the first term. How many x's need to go into x cubed? 2 of them, x squared. So then you go back. X squared times x is x cubed. X squared times negative 1 is negative 1x squared. Please, please do this. Put parentheses around the whole quantity and subtract. When people don't do that, they forget to distribute the negative to both terms. So x cubed minus x cubed is 0. Negative 2x squared minus x squared is just negative 1x squared. Bring down the negative 5x. And we're going to do it again. Negative x, negative 1x squared. I'm going to need another x that's going to be negative to go in. Negative x times x is negative x squared. Or you can write negative 1x squared if you want. Negative x times negative 1 is positive 1x squared. When I subtract, I am going to get negative 6x. And then I'm going to bring down the 6. All right, how do I get x to go into negative 6x? I'm going to need a negative 6. Negative 6 times x is negative 6x. Negative 6 times 1 is positive 6. You have a remainder of 0. You won't always have a remainder of 0, but if you do, that means that these two are factors and you can keep solving to find zeros. But we're not going to keep breaking down to find zeros just yet. We want you to get comfortable, and I just want you to use division, and I just want you to use long and synthetic division. We're not going to find the zeros just yet. So trying this method, go ahead and you try this example and see what you get. I want you to pause the video. I'm going to do it, and then you can check your answer. remember, if you didn't have an x, you'd put a 0x. If you didn't have a constant, you'd put a 0. We have a placeholder for each. X squared goes into x cubed and x time. Well, the book tends to put the x where the x's are. I don't care if you put the x here or here or here. It doesn't matter. Like I said, I'm flexible. I just want to see the answer. However, your professors and other courses might be more particular. X times x cubed, or x squared is x cubed. X times 2x is 2x squared. And then x times that 3 is negative 3x. Remember, we have to put the parentheses around it, so remember to distribute the negative. X cubes cancel. 3 minus minus is a 5x squared. Negative 13 minus minus is a negative 10x. And bring down the 15. How do you get x squared to go into 5x squared? You need a 5. So 5x squared minus 10x minus 15, get 0. Oh, perfect. So if you got x plus 5, you're good. Now, the whole purpose of why we're doing this, I don't think your textbook asks for intercepts or solutions, but the whole reason of why you're doing it is so that when you get the factors, x squared minus 2x minus 3, and you know when you multiply it together, it gets your original polynomial. Well, the whole reason why we're breaking them down is so that we can find intercepts. So if they ask for the intercepts, which I don't think your textbook's going to, but in other sections you're going to have to, you know that you have x plus 5. You know you're going to factor this trinomial, so it's x and x. Factors of 3 are 3 and 1. It's going to be a negative 3 and a positive 1 because you want to get that negative 2 in the middle. The beauty of math is you can check your work. X squared, yep. Positive 1, negative 3, make a negative 2, negative 3, yep. If you're still struggling with factoring, you need to Google factoring or Google factoring a trinomial where a is 1, okay? Then you set each piece equal to 0, so your intercepts are going to be 3, negative 1, and negative 5. Like I said, your homework is just going to ask you for this, not all this, but this is why we are doing it. All right, so this is dividing polynomials with long division. We're going to try doing it with what's called synthetic division or fake division. There was a mathematician called Paolo Ruffini. I think it was the 1700s. He came up with this, and it was called Ruffini's rule. And then textbook companies, I'm pretty sure, are probably what changed it and just called it synthetic division. So synthetic means fake because it's not real division, but we're using it to help us find our zeros. So when you're using synthetic division, you're going to take the solution it would be. So if x minus 1 is your factor, then x equals 1 is the solution. You're going to put that solution right here in its own little box. Like it's a prize, okay? And then you're going to use the coefficients. 1, is there something for x squared? Yes. If there wasn't, you'd put 0, negative 5, and 6. So we're just using coefficients to find your zeros, in a sense. So you're going to drop the first number, then you take your solution and multiply it. 1 times 1 is 1. Negative 2 and a 1 make it negative 1. 1 times negative 1 is negative 1. Drop your numbers, you're adding them, is negative 6. 1 times negative 6 is negative 6, and then I get 0. So you work backwards. Your remainder is 0, your constant is negative 6, your x is negative 1, and your x squared is here. My advice is if you've gotten this far in the video and you just went straight through, I would stop, do the first half of your homework, which is long division, then come back, watch the video, look at this, and do the second half of your homework. Okay? So your first factor was x minus 1. This factor here is x squared minus x minus 6. This is the same problem we had in the beginning. Oh yeah, x minus 1, x squared minus x minus 6. Same thing. So both methods should give you the same results for zeros. All right. This one says you try. So I want you to pause the video and I want you to try it. It says given 2 is a 0, 1x cubed, negative 3x squared. We don't have anything here, and a 4. So that's where people are going to make mistakes, is not putting in the 0. You're going to drop the 1. 2 times 1 is 2. Drop the next numbers. 2 times negative 1 is negative 2. Drop the next numbers. 2 times negative 2 is negative 4, 0. So it's going to be a remainder, a constant, an x, and an x squared. So 1x squared minus x minus 2. They want to know what the x-intercepts are. You have to remember that 2 up here was one of the factors. So your intercepts are 2 like they gave you, And then they're going to be a -2 and a 1. So 2 as well and a -1. So if you have two 2's, that just means that it was tangent to the curve. So it probably looks something like this. It's going to be like a Loch Ness Monster, but it probably went through -1, and then at 2, it just touched, like something like that. So when it's tangent or touching, that's why you have 2 answers. Is your textbook going to ask for this? No. Is your textbook going to ask for this? No. In the homework, it's asking for this, okay? So that brings us to the remainder theorem. It says synthetic division also comes in handy when to find remainders or just values of a function. So though synthetic division is substitution, okay? So let's look here. I have a function f of x equals -3x squared plus 5x plus 4. It says the polynomial that it's going to be divided by is x minus 3. What's the remainder? Well, if I substitute in +3, because that would be the solution, into -3x squared plus 5x plus 4, I'm going to get -27 plus 15 plus 4, -12 plus 4. I'm going to get -8. So my remainder should be -8. So substitution is remainders. Remainders is substitution. So let's try it. Let's try it with synthetic. If I put 3, because the 3 would be a solution because your factor is x minus 3, your coefficients are -3, 5, and 4. Oh, shoot. Drop the 3, get -9, -12, get -8. Yes, your remainder is -8. And then for long division,